Hi guys, and welcome back to a new video. Kotlin Multiplatform, and especially Compose Multiplatform, is making very fast and very cool progress. In this video, I will cover a new feature, a new dependency we have for KMP projects, because we can finally share ViewModel references. And that officially, so it is exactly the same Jetpack ViewModel reference that we know from native Android. And that now works for Kotlin Multiplatform as well. So those of you who have already used Kotlin Multiplatform in the past knew that we could easily share business logic between iOS and Android, that we could easily share data logic between iOS and Android. But doing that for ViewModels was always a little bit hacky. There were ways to do it, there were workarounds, but it never felt really solid. And now that this Jetpack ViewModel is applicable to Kotlin Multiplatform projects, that has an end. We finally have a very cool implementation of that. And the first step, if you want to follow along to see how we really make use of that, is to go to kmp.jetbrains.com, because we will create a Compose Multiplatform project here. So we'll also share the UI. And this is currently the only wizard that allows you to create such a project, since there is no template for that yet in Android Studio. So just enter the project name, package name, tick Android and iOS, hit download, extract the zip file, open that folder in Android Studio, and you are ready to start with the video. So there we go. I've opened this project, and specifically what I want to show you is, on the one hand, how we can use this view model, what kind of features it has, or just to show you that it has the same features as the native Android view model. But I also want to show you how it behaves with the DI, so with the dependency injection. Since, as you maybe know, injecting dependencies into a ViewModel reference is always a little bit tricky, also native Android development, since we need a ViewModel factory in order to create that. But I will show you a very cool way how we can also make use of that in Kotlin Multiplatform. And the first thing we need in order to start is we need to add some dependencies. For that, we want to open our Gradle scripts folder, open our version catalog, and in here I want to paste a few versions that we need to work with in this video. First of all, let me paste these versions. You, of course, could just write these off or get these from my GitHub repository, which I'll always link down below. Let's paste these. So we have a lifecycle ViewModel, which is the new ViewModel dependency, or where that comes from. Make sure to definitely use this version, since this is where it started to be KMP ready. And then we want to use Koin, so our dependency injection framework we want to use for Kotlin Multiplatform. Obviously, Dagger Hilt isn't working here, since Hilt generates Java code. That is not KMP ready, but Koin very much is. And we use Navigation Compose. So we also now have a Compose navigation framework for Compose Multiplatform. That is not the topic of this video, but we actually need some sort of screen where we can bind a ViewModel reference to. That's why I also added this dependency here. Then we can scroll down to our libraries block and just also add the corresponding dependency references. So for Koin Android, Android Compose, Koin Core, Compose, and Navigation Compose. So really just copy paste these and then sync this. And after that, we can add these to our Compose app Gradle file, which we can find here. We don't have any plugins, so we can scroll down to our source sets. Let's first of all add Koin specific dependencies to Android. So the Android specific dependencies by saying implementation lips.koin.android, and we want a lips koin android x.compose. So those are the Android specific dependencies for Koin, and the remaining ones we add to our common main source set, so to the shared code section of our project. Here you can see auto completion already does its job. We don't want coroutines, but we want the Koin core import. We want to add the new ViewModel reference, so we say lips.lifecycle, no, lifecycle ViewModel. How did I call that? Apparently I did not paste this. Sorry, let's paste the lifecycle ViewModel dependency as well. Of course, that is needed. Let's sync this. This will fail here. I hope it still lets us finish this off. So libs life, no. Let's remove this, try again, and after successful sync, we should also have these version catalog references here. So implementation lips lifecycle ViewModel, there we go. And we need the navigation compose dependency. So implementation lips navigation compose. This core Koin dependency, we actually want to use API for and not implementation. What is the difference? Well, if we use API, then it will also make the classes and files that this dependency includes available to modules that include our common main module. So for example, Android main and iOS main as well. And we just need those Koin functions in order to initialize our Koin application in iOS and Android main. So we can just add this once here for common main. And since both Android main and iOS main depend on common main, it will also have the dependencies that this API here adds. All right, then hit sync now. And after that, we are ready to implement our very first shared ViewModel reference. In order to do that, I want to switch to the project view. I like that a lot more. Open up our Compose app, source, go to common main. That is now where the magic happens. So our shared code section. And here we want to have a new class. Let's just call it main ViewModel. Make that a class. And you will see we can now inherit from ViewModel. That is what we can do. And this is not just a random class. No, it behaves exactly the same as our Jetpack ViewModel we know from Android. So we do have an onCleared function here. We can override if we want. We can react to when it's cleared. We do have ViewModel scope, so a coroutine scope bound to the lifecycle of our ViewModel. That is existing here. And what I now want to do is I just want to have a very basic timer which counts up every single second and then updates our UI so that we can see how this works. So let's have a private val underscore timer mutable state flow. Let that start at 0 and then have a public exposed version here where we say timer as state flow. Then we can have, it actually suggests exactly that. Let's hit tab to start the timer. We need some closing parentheses here, but we can use ViewModel scope if we import that. We need to import launch and we need to import delay. So we just have an infinite loop that lives at least as long as our ViewModel scope coroutine, and it delays the coroutine for 1 second and then increments our timer value by 1. That is really everything that happens here. We can also make this private and then call this in our init, so start timer, so that we immediately start counting up our state flows value when the ViewModel is initialized. All right, let's go to our app.kt file where we have some default Compose code. We can get rid of that and instead add a little nav host. So this really now works the same as for native Android. We have a nav controller, which we get with a remember a nav controller. And then we can pass this here. Nav controller is nav controller. And we set a start destination of screen A, for example. And then we have a composable for screen A and a composable for screen B. But we actually don't need the screen B composable. Since we just need one screen we can bind our ViewModel to. So let's import this composable, get rid of that. And in here, let's just have a box with a centered text, which will display our current time. So we have a fill max size modifier here for this box. Let's make sure that we have a content alignment of center. And then in here, we will have a text that should display our current timer, that toString, something like this. How do we now get this timer? For that, we of course need a ViewModel reference. And this works a little bit differently compared to native Android, because the challenge here now is that ViewModels are mostly a thing on Android. Or at least on Android, they have some kind of special place, because a ViewModel outlives the lifecycle of our UI, of our activity. And that is one main reason why we have these, since that way we can put our UI state in the ViewModel. And even if our activity gets recreated, gets destroyed, for example, after a screen rotation, then our state is still maintained and won't be reset. However, that is only really a problem on Android. On platforms like iOS or desktop, we don't have this concept of screen rotations. Well, on iOS we do, but on iOS the state is not reset after a screen rotation because we don't have this activity concept. And on desktop programs, we of course don't have any of that. But we still try to have one shared version of this ViewModel which is able to handle all these different platforms. And the easiest way to initialize a ViewModel is to say val ViewModel is equal to ViewModel. This is nothing new to you at this point, but there are some differences you will notice in a moment. So we can say main ViewModel here, initialize that, and then we get our timer where we say by ViewModel timer collect as state. Then we observe this, we display it in our text, and then let's just launch this and see how this works. Let's take a look at running devices. There we go. Let's move this over here. Oops. And after this build, we should hopefully see a center text that counts up once a second. Yep, there we go. And there's our text. You can see that counts up. And also if we rotate our device, then the timer will survive that screen rotation. So this view model now really behaves exactly the same as on Android. So far, this was really simple. But what now happens if our view model has a constructor? So right now, it's easy. It's straightforward to initialize that, but what if we have some kind of argument here? Whatever that is, a repository or whatever. For simplicity, let's just make this a hello world string. The moment we have that and we relaunch our app and take a look here, you will see our app crashes. If we take a look in Logcat, then you will notice, okay, there is no such method init that takes no arguments. So by default, if we have, where is our app here? By default, if we try to initialize a view model with this view model function, then that will only work if our view model has no constructor, because then this view model function knows how to construct that. If our view model does have a constructor, then we need to work with a view model factory. So what we can do is, in here, we can provide a factory where we say, okay, that's a view model factory. I'm actually not like this, but what we can do is we can use the initializer function. So like this, where we need to provide a view model reference. So you can say we have a main view model and we provide a hello world string. All right, if we launch this, then you can see now that works because we provided this factory, or we provided these arguments specifically for this view model, which is pretty easy in this case. However, very often when apps scale, then we use some kind of dependency injection framework. In this case, we need to manually construct a view model reference, which is of course not what we would expect if we have a dependency injection framework like Dagger or Koin in our case. So we actually want to inject the instance of this view model here. How can we now do this with Koin? All right, in order to make this work, we need to first of all set up Koin. And this won't be a pure Koin Kotlin multi-platform tutorial. I might make a separate video about that, but I just want to show you how we can use Koin in order to now inject our view models, including the dependencies that our view model includes. So here in our common main Kotlin source set, we want to create a Koin, let's call it Koin initializer. That will be a class, and not only a normal class, but an expect class. So if you're new to Kotlin multi-platform, this is a new keyword to you. So we have expect, and the counterpart is called actual. So there's an actual keyword. And this is pretty much comparable to just defining an interface here inside of our common source set, inside the shared code section, where we have the specific implementations, so the actual implementations for every single platform individually. So we will have an actual implementation of this initializer for Android in Android main, where we define how initializing Koin works on the Android side. And we have that for iOS main, where we define how that works for iOS. And this expect actual mechanism is just how Kotlin multi-platform deals with that. But the equivalent behavior would be just having an interface with a different implementations for every single platform, just that we don't use interfaces here. So we have a Koin initializer, and here we have a function init. And now you can see it marks this as an error because we mark this class as expect, and it now expects us to also have actual implementations of that. Let's change that. We can change that by going to Android main, so our Android save area, where we have access to Android-specific dependencies like the context reference, which is actually needed in order to make Koin run on Android. And now it's very important that we place this Koin initializer for Android in the same folder structure as we have it in the common main one. So here we have it directly inside of our Kotlin source set. So we also need to put it directly in the Kotlin source set of the Android main module. Don't put it in this PL coding, blah, blah, blah. Put it in Kotlin, new file, call it exactly the same, Koin initializer, make that a class, make it an actual class this time, which takes a constructor, since here on Android we want the context reference in order to set up Koin. And then we can have an actual function init in which we can now say we want to start our Koin application. So start Koin. We want to define the Android context by passing in our context. We can define an Android logger, for example, which is optional. And then we can define our Koin modules. So those containers that contain the dependencies we want to be able to inject in different classes. For example, this one here. But now we also need to define these modules, and that can be done in the shared section as well. So let's go back to common main, Kotlin. Let's have a new file called app module, make that a file. And here we have an app module where we say, okay, that's a module. And here we say, okay, we actually have a singleton of the string we now want to inject in our view model. So here, hello world, that is the string we then want to take, or we want to let Koin take and inject here in our ViewModels constructor. That is really the end goal here. But the string is really just a simplified version of any other dependency. This could be a repository, a database instance, whatever. What we also need is we need to provide ViewModels specifically with Koin. And this is again a little bit different because, as I said, on native Android, creating a ViewModel reference is a bit different compared to iOS. On iOS, we can really just create a new ViewModel class by saying main ViewModel and then passing our hello world string in here. Because on iOS, ViewModels aren't really bound to the lifecycle since we don't have this concept of the Android lifecycle on iOS. But on Android, we need to do that. So how do we deal with this with Koin? What we can do is we can again define an expect val here for our ViewModel module, which we actually don't define here, but we just say, okay, that's a module from Koin. And then we have the actual implementations of that, again, in our Android main and iOS main modules. So here in Android main Kotlin, we can have let's actually put that in a separate file. Having that in app module is a bit confusing, I think. Let's go to common main Kotlin, create our ViewModel module, make that a file, paste our expect val ViewModel module, and then we can go to Android main Kotlin, create a new file, also ViewModel module, make that a file, and here we now have our actual val ViewModel module, where we now have the actual implementation just for Android. Because for Android, we need to provide a ViewModel with Koin by saying ViewModel off. And this is a function that is only available on Android and not on iOS, which is why we have this expect actual implementation here for ViewModels. Then we can say we have our main ViewModel, double-colon in before, and then Koin will figure out how to create that as long as all of the dependencies that our main ViewModel needs are provided somewhere in a Koin module. So we can then go back to our Koin initializer in Android main and add our modules. On the one hand, the app module and our ViewModel module. So that is already how this works for Android. Let's also have this Koin initializer for iOS. We can just copy this class and paste it here in iOS main Kotlin. Call it the same. Yes, let's just go on. We will have some conflicts here because on iOS we don't have a context, so we can get rid of this constructor. We don't have a Android context and Android logger, obviously, so we can also get rid of that. But other than that, this is how this looks like on iOS. Now the last thing we need is this ViewModel module reference for iOS. This is something we haven't yet done. So in iOS main Kotlin, let's have a ViewModel module, make that a file, and here we have our actual val ViewModel module again, where we define, okay, here on iOS, we actually just make these ViewModels a singleton. So we say main ViewModel, double-colon in before, and here you will notice that we don't have this ViewModel off function since we are on iOS, which is really the whole reason why we make this separate ViewModel module. All right, a little bit of setup here, but the last thing to make this work is on Android, we need to create an application class. So a class that lives as long as our application, in which we can then initialize our Koin app. We can do this by going to Android main, Kotlin, or let's actually open our normal package structure here. And in here, we can create a my app class, for example, make this inherit from application. And then on create, we can then create our Koin initializer, pass in our context, so application context, which we have here in our application, and then call that init. And then we can go to our Android manifest to register this application right here in the application tag, specify a name, and refer to my app. On iOS, it works a bit differently. Here in iOS main, we have this main view controller, which is the kind of entry point for our iOS UI. And here, if we open this up a little bit, this Compose UI view controller, this has this configure block, which is just called once for this controller. So in here, we could also just set up our Koin injection. So here we can say Koin initializer. Here we don't need any constructor arguments, and we can call init to also make this work for iOS. Now, the last thing in order to make Koin work for multi-platform projects, especially Compose Multiplatform, is to go in app and surround our UI where we want to be able to inject something with Koin with a Koin context. So this works like this. We have a Koin context. Koin context. Is that what I'm looking for? No. Did I forget to apply the Compose specific Koin dependency? Let's take a look in the version catalog. Where is that? Let's open it. Here in Gradle, libs versions. Yes, it seems like I did not apply Koin Compose. So let's go to our Gradle file of our shared module. And here in common main, we of course also want to have an implementation of libs Koin Compose. Sync this, and then we should have a reference to this Koin context composable in here. Let's try to re-import that Koin context. There we go. This one here, add this, and then we can move our code inside here. So everything in here is now injectable with Koin. Now, normally in Koin Compose, if we want to inject a dependency inside a composable, we can say, okay, val ViewModel is equal to Koin inject, and we specify the reference we want to inject here. However, Koin inject will inject a new reference every single time this composable is composed. This is not really the behavior we expect from a ViewModel, because a ViewModel should stay active if we navigate somewhere else and then go back. So it should keep the state. It should keep executing the code inside the ViewModel, so ticking our timer in this case. So we need something else. And for that, we normally have specific functions that inject ViewModel references, which Koin also has, but just for Android at this point. I'm pretty sure it will add the corresponding ViewModel function in future to easily inject a ViewModel by just saying Koin ViewModel or so, without us needing to specify how creating this ViewModel works. But so far, it does not have that because it's a very new dependency with this Jetpack ViewModel. But we can very easily create this on our own. So what we can do is we can scroll down, have our Koin ViewModel function, which returns some kind of type of T. We need to make sure that T is actually a ViewModel reference. And then in here, we need to get a reference to the current Koin scope, which allows us to inject dependencies at a very specific time. So equal to current Koin scope. And here we need to add the composable annotation to this function, since current Koin scope is a composable function. So we retrieve the current Koin scope, and then we make use of our ViewModel function with the initializer. And here we can then say scope.get, and we get a ViewModel of type T as long as that is provided. We still have an issue here because we're dealing with a generic argument, and that is not known during compile time what that is, but it is if we actually add the reified keyword. So Alt-Enter, make T reified and inline, and then we have no more issues. So in short, what happens here is we create a function that is callable, or where we can pass any type of ViewModel reference. It returns exactly that ViewModel reference. And with this scope.get, we just kind of look, okay, do we have any module where this specific ViewModel reference is provided? And if so, please inject that here. We put this into such a proper ViewModel block here to really bind this to the lifecycle of our screen. And then this is also recognized here. We can inject our ViewModel with Koin. And just in order to test this, we can go to our main ViewModel and just print our hello world string. So we see that the injection really works, since the hello world string is now provided here in our app module. Let's launch this on Android. Take a look at how that looks like. There we go. Our timer is ticking. And if we take a look in Logcat, there is our hello world string. So this works fine, but we still have to test this on iOS, of course. In order to do so, we need to open up our project hierarchy, then scroll down to our iOS app directory, open that up, open up the Xcode project folder, and then right click on Xcode workspace and open that in Xcode. Then an Xcode window will open up. Here we can choose a specific emulator we want to launch this on, like iPhone 14 Pro in my case, and then we launch this and hope for the best. Build succeeded. That is looking good. Our timer is ticking, so the ViewModel reference is also working on iOS, but let's also take a look at our logs here, and there's also our hello world string. So our Koin injection works for iOS as well. I'm pretty sure this will change a little bit in future how Koin injection here works for this Jetpack ViewModel on KMP, but this is already something how you can set that up right now with not too much of extra effort. Awesome, that's it. I'm, by the way, looking for a few more participants for my 10-week mentorship program, which will start the next round at end of May. So if you want to work together with me really closely to work on your technical Android skills, on your technical KMP skills if you want, then click the first link in this video's description, apply, and if that seems to be a fit, we will hop into a call to talk about all the details. Thanks so much for watching. I wish you an amazing rest of your week. See you back in the next video. Bye bye.